Welcome to Maths Made Easy. Today we are going to solve question number 11 to 20 of exercise number 7.2, chapter 7, class 12, that is integral. So let's start. By the way, these are some basic results that you may need in your problem solving. So please take screenshot of this. Question number 11. X upon under root of x plus 4, where x is greater than 0. So in this question we are going to substitute x plus 4 as t. X plus 4 is equal to t. Therefore we get the value of x as t minus 4. This x will be replaced by t minus 4 and x plus 4 will be replaced by t. At the same time, the value of dx is equal to dt by taking derivative of this term. So we have dx is equal to dt. Now let's put in the values. I is equal to integral of t minus 4 root of t dt. This can be written as t minus 4 times t to the power minus 1 upon 2. Since this root t we can write root t as t raised to 1 by 2, and from denominator it's shifting to the numerator. That's why we can write t minus 4 times t to the power minus 1 upon 2. Now this t will go inside the bracket. Let's see what happened with that. So t minus 4, t times t to the power 1 upon 2, that is t 1 times t minus 1 upon 2. By law of indices this becomes t 1 upon 2, and similarly with 4 there is nothing, so we can write t to the power minus 1 upon 2. Hence we have this. By applying integral, we can write t to the power 1 upon 2 plus 1 whole divided by 1 upon 2 plus 1. T to the power minus 1 upon 2 plus 1 whole divided by minus 1 upon 2 plus 1. Since integral of x raised to n can be written as x raised to n plus 1 whole divided by n plus 1 plus c. By using this law, I can write this. Now just a basic simplification and you will reach here. I is equal to 2 times of t to the power 3 by 2 divided by 3 minus 8 times root of t plus c. Don't forget to resubstitute the value of t that we have already assumed here, that is x plus 4. Hence, this is our solution. Let's move on to the next one. By the way, if you can remember, try to remember this. Integral of 1 upon root 2 is equal to 2 root x. I'm sorry, integral of 1 upon root x dx is equal to 2 root x. Question number 12. This is very important. Pay attention to this. X cube minus 1 to the power 1 upon 3 x raised to 5. If you take this as t, how will you get the value of x to the power 5? Well, we have a solution for that. This x to the power 5 can be written as x to the power 3 and x to the power 2. If we take x to the power 3 minus 1 as t, so we got already the value of x to the power 3, that is t minus t plus 1. This will replace our first term. X square will be replaced if we take derivative of this, because now it is 3x square is equal to dt upon dx. So x square can be replaced by written as dt upon dx 3, or x square dx can be written as dt upon 3. So let's do this. Okay, let us substitute x cube minus 1 as I told you before. Now taking the derivative of this, this x to the power 5 can be written as x is cube plus x cube times x square. I have already substituted the value of t, x square dx, and the value of x cube. Now I will be taking 1 upon 3 common out of the bracket, and then this out of the integral, then t to the power 1 by 3 will go inside the bracket. Let's see what happened with that. Here, same. I am taking 1 upon 3 out of the integral, and 1 upon 3 t to the power 1 by 3 is going inside the bracket. So we have 4 by 3, we have 1 by 3 inside the bracket. You can say this. Now just a basic formula of integral, that is x to the power n, can be written as x to the power n plus 1 upon n plus 1 plus c. So you have, and don't forget to resubstitute the value of t. Let's move to the next one. X square upon 2 plus 3x cube to the power 3. Let us substitute this term as t. So we have in denominator we have t cube. And how about x square? This will be diminished when we take derivative of this t. Okay, already substituted derivative, and x square dx can be written as dt upon 9. Okay, let me substitute it. So our integral x square upon 2 plus 3x cube to the power 3 dx can be written as 1 upon 9 integral of 1 upon t cube dt. Now we all know 1 upon anything, this will shift to the numerator with t raised to minus 3. Now applying the basic integral formula, n plus 1 upon n plus 1, we have t to the power minus 2 upon minus 2. Now resubstitute the values of t. 9 times 2 is 18, and this minus sign here, minus 1 upon 18 times 1 upon t square plus c, but the value of t is 2 plus 3x cube. So this is our final answer. Let's move on to the next one. 14. Question number 14. 1 upon x log x to the power m, where x is greater than 0 as well as m is not equal to 1. I am substituting log x as t. Since the derivative of log x is 1 upon x, so my x 1 upon x and dx will be used for dt. Integral 1 upon x log x m dx can be written as integral of dt upon t raised to m. Further, this t will go on in numerator, t to the power minus m. Now using the basic integral formula, m minus m plus 1 minus m plus 1, but don't forget to substitute the value of t. Okay, what is happening here? It's nothing, it's just arranging for the better visual. Since minus m plus 1 can be written as 1 minus m. That's it. Let's move on to the next one. X upon 9 minus 4x square. Same. I want to leave this for you all, but I will solve it very quickly. Let's take this as t. So when you make derivative of this, you will get minus 8x. So this x and dx is already sorted. Let's see how. I is equal to minus 1 upon 8 integral of 1 upon t dt. 1 upon t integral of 1 upon x is log x. So 1 upon t can be written as log of t. Later we will substitute the value of t. That is it. E to the power 2x plus 3. Well, you can take this as t or anything, but I would like to solve it very easy way. The basic concept of integration. What it says: integrate and divide it with the derivative of the function. If the function is composite function, this is composite of exponential function and algebraic function. So first of all, you should be knowing that integral of e raised to x is what? E raised to x, integral of e raised to x is e raised to x divided by derivative of x, and the derivative of x is 1. That's why always it is not visible, but it is there. So in this case, I'm going to integrate e to the power 2x plus 3 dx as e to the power 2x plus 3 and d upon dx of 2x plus 3. You will see. Here. Now derivative of this term is 2. That is it. This was very easy. You could have also done it in this way, the complicated way, that is let 2x plus 3 is equal to t. Now d upon dx. Anyways, you are doing here also. D upon dx of 2x plus 3 is equal to d upon dx of t. And then this is 2 dt upon dx. You substitute this here. I don't, if you can do it in simple way, don't go complicated. Question number 7. X upon e raised to x to the power 2. Okay, let's take this x to the power 2 as t. Since the derivative of this is available in numerator, always remember, if we are for the substitution, this comes with a practice, but it is always helpful to know the trick. The expression whose derivative is easily available, we are going to substitute that as t or m or whichever variable you are comfortable. So derivative of 2x is a derivative of x square is 2x. Since x is available in the numerator, with 2 I can play around. I can, if there is no, I can add. If there is extra, I can send it to LHS, RHS, anywhere to get my question done. Okay, I hope this is clear. 1 upon 2 integral of 1 upon e raised to t dt. It can be written as e raised to minus t. Now applying a simple e raised to t can be written as e raised to minus t. Now when you go for integration of this, what you do, like last time, e raised to x is equal to, integral of e raised to x is e raised to x upon dx of x. So this becomes 1. So basically e raised to x upon 1. In here, e raised to minus t upon d upon dt of minus t. This is minus 1 here. But don't forget to resubstitute the value of x. I mean the value of t. The value of t is x square. So I am going to substitute here. Instead of minus t, I will get x square. Okay. Question number 18. E to the power tan inverse x upon 1 plus x square. Now, see whose derivative is available. If you remember your derivative classes, derivative of tan inverse x is 1 upon 1 plus x square. So in this case, I am going to take this as t. Since its derivative is easily available, the question is you should be remembering those derivative. So let's substitute tan inverse x is equal to t. Derivative of tan inverse x is equal to dt upon dx. This, when you write derivative, you will get 1 upon x minus x plus x square dx is equal to dt. Now this part here is dx, can be replaced with dt, and this is t. You will see how simple it is. This was our expression, and later it can be written as e raised to t dt. Now you know the integration of e raised to x or e raised to t with respect to t. it is nothing but e raised to t plus c. Later substitute the value of t, e raised to tan inverse x plus c. Question number 19. A very tricky question. E raised to 2x minus 1 upon e raised to 2x plus 1. Can you find derivative of numerator in denominator, or the derivative of denominator in numerator? There is no available. We are going to adjust dividing numerator and denominator with e raised to x. If I divide here e raised to x, 1 upon e raised to x can be written as e raised to minus x. So finally we reach here. Now I think you can see the derivative of this term is available here. E raised to x plus e raised to minus x. Derivative of e raised to x plus e raised to minus x can be written as e raised to x plus e raised to minus x upon minus 1. It is e raised to x minus e raised to minus x. So I am going to take this term as t, and this term will go with dx to make dt. Clear? Let's substitute e raised to x plus e raised to minus x is equal to t. So we have reached to our integral of dt upon t. This can be written as log of t. We all know 1 upon x, the derivative of integration of 1 upon x is log x. So 1 upon t with respect to t is log t plus c. Don't forget to resubstitute the value of t. E raised to x plus e raised to minus x plus c. Finish. Let's move on to the last one. A similar kind of question. You can see the derivative is available for this one. Since this e raised to 2x plus e raised to minus 2x can be written as, when you write d upon dx of this, e raised to 2x whole divided by derivative of 2x, that is 2, plus e raised to minus 2x whole divided by derivative of 2x, that is minus 2x. Later we can take this 1 upon 2 common, and here e raised to 2x minus e raised to minus 2x dx is equal to dt upon 2. So I is equal to 1 upon 2 integral of 1 upon t dt. Again 1 upon t is log of t. Don't forget to resubstitute the value of t. Hence we got our answer. I hope you like this video. If you did, then please subscribe to my YouTube channel. I will see you in the next one. Thank you very much.